So, good morning, everybody. I'm very pleased to welcome you to our plenary for today. So, I'm Sabine Wurzler, and my co-chair is Xavier Querol. And we are looking very much forward to our today's plenary by Laurence Rouy. She will talk about particulate air pollution in Europe, main drivers and control strategies. Laurence is just sitting next to me here. I'm very happy that she made it. And I think Xavier will tell you a little bit more about Laurence, who she is and what she's doing.
Okay, thank you very much. Laurence is a scientist very well known in the air quality modeling community, in the gap between science and policy in Europe and especially in the United Nations. Laurence is the head of the Environmental Modeling and Decision-Making Department of the Chronic Risk Division at INERIS. If I am not wrong, this is a public company, a public organization in France. She received her PhD in 1995 in the field of applied mathematics. Since 15 years, she has developed the skills and competencies being leader of the research activities closely linked to the operational applications. The PREVER system is one of the examples of such projects that she developed in her team 10 years ago and in cooperation with other partners to answer to policy makers' expectations, taking advantage of the current know-how in the field of air pollution. She participates actively to the air quality monitoring strategy in France, providing technical expertise to the Ministry of Environment in charge of these air quality issues. Since September 2014, she is the chair of the EMEP steering body in the United Nations, the Convention for Europe, within the Convention on Long-Range Transboundary Air Pollution. She takes part of the management board activities related with several scientific European projects, especially in the 7 framework initiatives for the development of pre-operational Copernicus GMES atmosphere services, and coordinates in the framework part of regional air quality services development. So it's our pleasure to give the floor to Laurence Rouy.
Thank you very much, Xavier and Sabine, and good morning, everyone. It's really a pleasure to be here with you for this very important conference on aerosol PM issues. As said by Javier, in fact, I work in a public institute dedicated to the provision of technical support to the ministry in charge of environment in France, and also the chair of the EMEP steering body within the Convention on Long-Range Transboundary Air Pollution. And this is the reason why I decided to take those 2 hats for this presentation this morning and to share with you some views and insights related to the implementation of air pollution policies and more specifically PM control policies rather than developing some scientific issues that you are the experts for the scientific issues. So I decided more to share the policy side views and also to see with you why your work, what your research, your results are so important for the policy makers and what is also expected. So, particulate air pollution in Europe, where are we now? Air pollution, first, is still the first cause of premature death in Europe. And with this sentence, you understand why is it so important to work on air pollution still nowadays in Europe and everywhere in the world. We started really to be aware with air pollution issues and air pollution impacts on human health when in August 2003, maybe you remember, There was this heat wave in Western Europe with very, very high ozone concentration, an ozone episode for almost 2 weeks, which has been defined as responsible for 30,000 premature deaths. Then in 2011, there is this very, very important and reference study, which is AFECOM. This is a cohort study dedicated to PM, which involves 25 European cities covering 39 million of inhabitants in Europe. And with this study, it has been demonstrated that fine particulate matter concentration, PM2.5 concentrations, exceeding the guideline fixed by WHO, would be responsible for 19,000 premature deaths each year. It's a lot in Europe, in those European cities, not in China, not in India, in Europe. Also, you remember certainly that in 2013, the International Agency for Research on Cancer published this very important information classifying air pollution and particulate matters as carcinogenic. And in the same year, the World Health Organization revised some evidence of health aspects of air pollution in Europe. It was a work that has been conducted also within the framework of the revision of the thematic strategy on air pollution by the European Commission for the revision of the legislation related to air pollution. And in 2014, still the WHO revised its estimation of health burden. And their publication says that almost 600,000 of deaths in Europe are due to air pollution. It's, of course, a lot, and 600 of deaths. And we also have to think about other impacts like non-fatal heart attacks, aggravated asthma, decreased lung function, all these respiratory cardiovascular issues that impact population and European population. So, air pollution, impact of air pollution on human health. I don't talk about ecosystems, but there are also impact on ecosystems are evident. There are some figures that demonstrate that this is very important to deal with that. For instance, following the AFECOM study, it has been demonstrated that there is we can expect gains in life expectancies for 30 years people living in Europe, in various cities in Europe, if the WHO guidelines values could be respected for PM2.5. And for instance, you can see here, you can see here that in some cities like Bucharest, Budapest, the gain in life expectancies is about 20 months in a life. It's a lot. Those are other maps of describing the impact of PM2.5 on health regarding various indicators. In fact, an indicator, as I just said, that is really considers the loss in life expectancy. You can also consider another indicator, which is the number of years of life lost. This is the YOL indicator, which is very well known by the policymakers. And here you have a map which is produced by EASA. EASA is the International Institute of Applied Science Analysis in Vienna. EASA works for the European Commission and provides some insights to support the definition of European legislation in air pollution. EASA is also working for the Convention on Long-Range Transboundary Air Pollution, and it provides also scientific work to define relevant objectives to control air pollution in Europe. So here you have the loss of life expectancy due to PM2.5 exposure, and here you have a map which is provided by the European Environment Agency, which represents the years of life loss in Europe. And you can see that there are some areas in Europe that are really concerned by PM2.5 exposure, especially where we are today, but also in the Benelux, in the east part of Europe. And those areas, of course, and also in all the big cities. But this is really a matter of concern for the policymakers. However, there are things that can disturb the policymakers, but also the general public. The fact that when you compare emission reduction since 2002, for instance, you have here, this is a graph provided by the European Environment Agency, and this is a presentation of the decrease, the strong decrease in pollutant emissions since 2002. And this is really significant. And in comparison, here you have the fraction of the urban population so exposed to air pollution exceeding WHO guidelines. And what you see is that, of course, you don't have the same response. So a lot of efforts have been made in Europe to reduce emissions, but those efforts, the response to those efforts is not in the same proportion when you look at the health impact. And this is very disturbing for the policymakers, but also for the public. We don't understand. Why? You know that this is because it's very complicated, but it can explain why air pollution is still really a high matter of concern for the general public. And when you look at some surveys, especially the Eurobarometer's results, you can see that in Europe, air pollution is the first environmental concern of the European citizens. More than 50% of European citizens consider that this is the main issue and this should be the priority for the policymakers. And the policymakers, of course, listen this and try to do something to frame this issue with the legislation. So there is a legislation within the framework of the European directives, the Air Quality Directive, the National Emission Selling Directive, and at the United Nations level for the European Commission, the Economic Commission for Europe, you also have this Convention on Long-Range Transboundary Air Pollution, which fix some objectives, some quality objectives regarding the health impact, regarding the impact of ecosystem to control air pollution. And those objectives are the basis of all the air pollution legislation, regulation. So the objective of legislation is really to find the good balance, to find the good compromise between emission reduction strategies that have a cost for the activity sectors, for the industry, for traffic, for the citizens, if they cannot take their car, for instance, for agriculture, for farmers, a cost for everyone, and the benefits that you can gain when you improve your life expectancy, when you improve your quality of life, decreasing the number of cardiovascular or lung disease. So this is the basis of all the policies that are developed in Europe and elsewhere. And to define these policies, there is a number of endpoints, what we call endpoints as those indicators that we try to improve reducing emissions. So they relate to mortality. I just talked about YOL and reduction in life expectancy, but also in morbidity. And here you have the list of health impacts that are taken into account, for instance, in cost-benefits analysis related to the CAFE program. CAFE is a Clean Air for Europe program from the European Commission. And this table comes from a report of the thematic strategy for air pollution. What is this? Should we stop? No? Okay. Okay, published in 2014. And you can see you have some examples of the indicators that are taken into account when you try to regulate air pollution. For instance, respiratory hospital admissions, chronic bronchitis. The cost of chronic bronchitis is very, very high. Restrictive activities days, including lost working days. So this is the economical aspect of air pollution. Respiratory medication use, depending on the age of the target people. So here you have this list of indicators that are taken into account when you try to regulate air pollution. And when you try to regulate, you have to think about money. You have to think about euros or dollars. And this is the reason why all those indicators, there is a value, a monetary values for all those indicators, which allows to build up this balance between the cost of reducing air pollution with abatement strategy and the benefits that you can take from those strategies. And here you have some examples which targets PM2.5 effects. For instance, the cost. Those are assumptions, of course, for the studies that are conducted at the European level, but those are robust assumptions because all the studies are based on such assumption. And with such approach, WHO in April 2015 and OECD estimated that the cost per year of air pollution in Europe is about $1 trillion of US dollars. And among this, the cost of illness is 10%. So when you consider this kind of figure, it's obvious that action against air pollution is worthwhile anyway, even if there is a cost. Of course, we always have to look for the right balance, but the amount is so amazing, so huge, that it's urgent, even in Europe, to do something. Few words about the Convention on Long-Range Transboundary Air Pollution. It's an active body since 1979, and since 1979, this convention, acting under the UNEC, which is the United Nations Economic Commission for Europe, tried to build up an area of discussion of policy discussion related to air pollution. And the convention has published 8 protocols to reduce the impact of air pollution in Europe. And we can say that it's a successful initiative which is based on a large amount of scientific work thanks to the effort of all the parties that have ratified this protocol. This convention, sorry. There are 51 parties talking together, trying to do something to reduce air pollution in Europe. It is helped by various bodies, and especially the EMAP program, which in fact drives a well-known EMAP monitoring network. I guess that you have heard about it. There are some part of this monitoring network in all European countries, and also a modeling program to assess background air pollution and the impact of emission reduction strategies. And of course, since I don't know, but for several years, aerosol, particulate matter, but also black carbon, considering interlinkages with climate change, is one of the main areas of interest of this convention. I would like to mention also that the EMAP program coordinates monitoring activities in the parties, but also intensive observation periods. And since 2008, we try to focus those intensive observation periods on PM issues, understanding PM composition and PM main drivers. And also, there is an intense cooperation with the research networks and infrastructure, for instance, in past USAR, and also the Actress network and all the PM community. And really, I think it's very important that this convention and national experts from this convention could have close cooperation with those research infrastructure. What's the status in Europe? So what can we say? In fact, roughly speaking, In Europe, we can say that there is a large gradient regarding PM10 and PM2.5 concentration. PM10 concentrations range in Europe from 5 to 55 microgram per cubic meter regarding the annual mean. I just mentioned that the limit value according to the Air Quality Directive for PM10 is 40 microgram per cubic meter annual mean. PM2.5 concentrations in Europe range from 3 to 25, 30 microgram per cubic meter. And of course, it's very interesting also regarding the legislation, but also the fact that we are submitted, we have to bear the effect of high episodes of PM pollution. It's interesting to see how it works for a whole year. Here you have the representation of exceedances of the daily limit value, which is 50 microgram per cubic meter, during 1 year. The year that we have chosen is 2009. And this is an average of PM concentrations all over Europe for various kinds of stations, so rural, suburban, urban traffic, and industrial. And what you can see is that there is really a cycle of PM pollution in Europe with very, very high level in winter, also in spring. There is a quiet period in summer, and then in November, December, it comes back. And this kind of picture is very interesting for the policymakers because they have to think about, of course, long-term control strategy, but they also have to manage short-term issue information to public, trying to reduce the impact of episodes. So it's very important to know when they have to be really aware about what will happen. So you see how it goes in Europe. Here is the map of the PM background concentration in Europe in 2013. This is published in the EMAP status report. This report, you can find it on this website. And what you can see here is that here you have PM10 concentration and here PM2.5 concentration. This is very close to the maps that I've shown representing the health impact. There are some geographical region areas in Europe that are a bit problematic with quite high concentrations, which do not decrease actually. Of course, you have the cities, but not only the cities here. Those are the rural background. EMAP focus on the rural background of air pollution. And here you have areas, so in the Po Valley, in the eastern part of Europe, where air pollution, PM pollution, is really a concern. Here are the trends that are established by the EMAP centers, considering all the PM measurements that are implemented in the EMAP domain. And here you can see for some stations a bit everywhere in Europe, in Australia, in Switzerland, in Germany, Finland, Norway. You can see the trends since 1997 to 2011 of PM pollution. So those are PM10 concentrations and PM2.5 concentration. It decreased. There is an average decrease of 18%, but with this uncertainty. But it doesn't decrease very fast, very quickly. And when you look at what is measured in all the cities, considering the data that are reported by the member states to the European Environment Agency according to the Air Quality Directive, so all kinds of measurements are reported, including urban measurement, you see that there are many, many sites still in Europe. This is a map for, this is published in 2014, so this is a map, I guess, for 2012, yes. This is the situation of PM10 concentration, annual average in Europe. And you see that there are many, many sites where the limit value of 50 microgram per cubic meter is still exceeding. So you have on one side, and, sorry, I just forget to comment this, those are PM2.5 concentration, and this is a kind of classification of the countries. So this is the countries, the PM2.5 concentration, average over 3 years. This is an indicator taken into account by in the European directive. And you can see that there is a huge gradient regarding PM2.5 concentration between Finland and Bulgaria, and that there are some countries where PM2.5 remains a big problem. So on one side, you have this situation, which is, we cannot say it's completely bad, but there are some areas where there is an urgent need to do something. You have the health impact, you have the economical cost. So that means really that air pollution control remains a challenge, a real challenge, but this is also essential to deal with it. So this is a very obvious, just a very obvious slide saying that for considering this challenge, one part of the challenge is that on one side we have those primary particles on which we can do something directly, and those secondary particles, and we have to do something on the precursors like SO2, NO2, or VOCs. Another point which makes the problem very complex is that PM pollution is certainly a complex alchemy between local emissions and long-range transport. This is a very high-resolution simulation that we did in my team. This represents the PM2.5 concentration in January 2009, computed with our chemistry transport model, which is called CHIMER, with a 2-kilometer resolution all over Europe. And with this kind of picture, you see how, you see how local sources located, especially in winter, in cities, in big cities, merge to become a long-range transport issue. And this is even more evident when you look at this kind of map that we elaborated with the CHIMER model. This is still for the 2009. This is a reference year because it is considered as a medium year, in fact. And for each season, so this is winter, this is spring, this is winter, this is spring, fall, and summer and fall. This is, in fact, we have tried to represent the main fraction, the prevalent fraction regarding the PM compounds in PM concentration. And what you see, so what is green represents secondary anthropogenic PM, what is pink represents primary PM, brown is dust, and blue is sea salt. And what you see is that there are some areas where, whatever the season, the prevalent fraction is primary PM, so that means that this is certainly linked to local emissions. But in almost all the year, the prevalent fraction everywhere in Europe is green. That means secondary anthropogenic PM, aerosol, and that means transboundary air pollution. So there are those areas where certainly local action could be efficient, but everywhere else, coordination of actions among countries in Europe is essential. We have tried, I think that this is very important for the policymakers, to establish PM episodes typology. And we have decided to classify in France, but I guess that it can be the case in other countries, the PM episodes in various classes. So we have very well-known winter episodes, PM and NO2, which occur under cold weather, anticyclonic conditions, strong inversions of temperatures, and they occur when the weather is so cold that residential heating emissions are very, very high. So there is a large influence of residential heating sector during those episodes, and also road traffic. Road traffic is always an issue. I will not talk a lot about road traffic during my presentation. I will focus on other issues because it's obvious that everyone has to do something with traffic, each country. You also have spring episodes developing under anticyclonic conditions still, with cold temperature during the morning, which create strong inversions, but temperature also increasing during the day. And with those increasing temperature, because during those periods in spring, in late February, March, April, you have a high level of agricultural activities. There are ammonia emissions that are due to volatilization from manure fertilizer spreading. And really, we know very well now this kind of episode. I will come back to that. There is really a clear link between agricultural activities in spring and those spring episodes. There are dust episodes sometimes. This is influence of fluxes from the Saharan. And sometimes this is something that we are concerned by in France. It crosses the Atlantic Ocean and impacts Guadeloupe and Martinique. And sometimes there are PM episodes which are due to volcanoes. You remember the story of the Icelandic volcano. Perhaps it will happen in the future. It happened in 2010. There was an impact in last year in September 2014, and maybe it will happen again, but we cannot do anything for that. This is very important for the policymakers to know about natural PM event, natural dust, volcanoes, to inform the public, to quantify this contribution, because of course, when you report PM exceedances, if the exceedances over the limit values are due to natural event, you have to know that, but you cannot do anything, of course. To anticipate those events, there are very, very interesting projects and work in Europe. I just mentioned here the activity of the Copernicus Atmosphere Service, which is a new project dedicated to environmental monitoring in Europe. And there is a website where information about air quality in Europe is published, especially forecast of dust aerosol. And with this information, the policymakers can anticipate what will happen, whether it may occur that some very high level of PM in his country could be due to PM. Let's come back to anthropogenic air pollution, and I just take an example, the example of France. So this is just a chart showing, in fact, the composition of PM in a reference measurement site in France during PM episodes, and since 2010. So for each year, here you have the months, November, December, January, February, March, April. Episodes occur in France during those periods, and we evaluated the chemical composition of PM during those episodes. And you see the typology that I just mentioned. In fact, you can see that in winter, the major part of PM compounds is made of organic matter. But in spring, March, April, you see the part of yellow and blue, nitrate and ammonium. This is an inorganic part. Ammonium nitrate connected with agricultural activities, certainly. And you can see that during those episodes, we consider that it can be more than a half of the PM compounds, in fact. This is the reason why it's very, very important to consider also this activity to define future control measures. Here you have an evaluation of the impact of the Gothenburg Protocol, the revised Gothenburg Protocol of the Convention on Long-Range Transboundary Air Pollution, which has been established in 2012. And here, so this protocol sets a number of national emission ceilings for the parties that have ratified the protocol, national emission ceilings for 2020. And here you have simulated by several models. So here you have the Chimère model, the French one, the EMEB model, the reference one, and the Lotos Euros model, the Dutch one. So you have the impact of this protocol in 2020 on PM10 concentration. And what you can see is that in some areas, especially in those areas that are roaring areas regarding PM concentration, there is an interesting impact, a significant reduction of PM10 concentration. So this is, I think that we all agree on that because all the models simulate more or less the same thing. And so started from this and considering that in the protocol, in the Gothenburg Protocol, the objectives for ammonia emission reductions are very, very weak, few percent in each country. We try to analyze the possible effect of being more ambitious on ammonia emission reductions. And this is a model intercomparison studies that have been performed by my department for the European Environment Agency. And here are some results. So here you have, as I said, the reference year is still 2009. So you have the PM10 average concentration, annual average. This is a reduction, the PM10 reduction in concentrations due to a 10% ammonia emission reduction. And of course, what you can see is first that the model results are very consistent, so it's a good thing. The simulation, the exercise is robust, but this is not so high. In fact, you can reduce the PM10 concentrations by a few 0.2, 0.3 microgram per cubic meter for a reduction of 10%. So you can imagine that for a reduction of few percent of ammonia emissions, it's nothing. The results is much more significant if you reduce ammonia emissions by 30%. Of course, I know 30% it's a dream, or no, not a dream, a theoretical assumption. It's impossible if we listen to the agricultural sector, but here is the effect, and this is much more significant. And once more, here you have maybe a bigger effect for EMEB, especially on Po Valley, but the results are more or less consistent, and it shows that in fact, okay, when you reduce by few percent, 10%, it's almost nothing, but it becomes interesting when you reduce by more than 30%. The problem is that, of course, this is not realistic. This is what is considered by the policymakers. So discussion should continue with the agricultural sector, looking for strategy, win-win strategies between policymakers and agricultural workers. Another point, Another topic I would like to share with you is wood burning and residential heating. You've seen that in the graph I show you with the composition of PM during PM episode in France, that in winter, the part of residential heating could be very high. And of course, it's obvious. It's obvious because the temperature are very low. So people increase residential heating, use wood burning, open fires, because also this is during the Christmas period, it's nice and so on. And because sometimes in some periods the weather can be very cold with very strong temperature inversion, the pollution, PM pollution, stays stuck near the ground. However, we consider that this is a main driver in winter, but this is sensitive to geographical areas. We consider this is not the same situation everywhere in Europe. Just to illustrate this very interesting picture from Fuller 2013, comparing a PM10 due to wood burning in Paris and in London. And here you have Paris in grey, London in black. And you can see that the cycle is not, this is for 2009 and 2010, is not completely the same, and the levels are not completely the same in the two cities. In France, but also in all mountainous areas, this can be really a very big issue. Here you have some results from measurements, a field campaign that has been organized in the Alpine Valley. And you have to know that in France, the Alpine Valley is really an issue for PM. This is one of the most polluted areas in France. And when you look at the composition of PM in this area, you see that most of PM compounds are here represented in green, and this is biomass burning. So that means, once more, that we certainly have to do something with biomass burning if we want to deal with winter PM episodes. Regarding the legislation, the current legislation, there is a knowledge of this issue. There are big improvements, but a lot remains to be done, especially because there are still very high uncertainties on the emissions that we can allocate to biomass burning. I would like to mention this very interesting study from TNO, from Denier al. 2014, and he revised the emission of wood due to wood burning in Europe. And you can see that this is one of the former emission inventory, and here you have the new emission inventory established by TNO, especially for Copernicus activities. And you can see that the part of wood burning increased a lot. So that means that in the past, during the first phase of discussion, political discussion related to PM management, certainly we have underestimated the part of wood burning in PM concentration. What are the current challenges for the policymakers with PM pollutions? I just showed you few examples, few questions that remain very alive in the discussion, I guess, in all the countries, at the European level, in the UN conventions. If we try to summarize what we have to deal with, it's true that all the simulations show that current emission control strategies that are established under the convention or under the National Emission Ceiling Directive revision give promising results with significant reduction of PM concentrations in Europe. However, if you look at the maps or the results, there are some areas in Europe or some periods during which the PM concentration level are still high. That means that some improvement are still expected. We expect improvement in emission inventory. It's true that I am a modeler, but I don't want to say that models give not very good results because of emission. That's not true. But to be honest, there are still some high uncertainties we have to deal with considering emission inventories, and especially the emissions that are reporting according to the regulatory processes like the National Emission Selling Directive or the Convention. Especially, we request some improvement in spatial temporal distribution of emissions. You've seen, I've tried to show you how the episodes and so the pollution level depends on the period. It is connected to the activity, it is connected to the weather, the temperature, and we have to understand a bit more how it works to be in a better position for anticipation of PM episode and anticipation of high level of PM pollution. We also need increasing efforts in some countries of Eastern Europe. In fact, there are very, very large uncertainties regarding emission inventories in the eastern part of Europe. And of course, it influences the whole of Europe. I show you that the problem is really a transboundary problem. I would like to mention that for the first time within the Convention on Long-Range Transboundary Air Pollution, black carbon emissions have been reported by 17 countries for the past year, and this is a very positive signal from policymakers in countries that try to assess not only PM as a whole, but some compounds that can be problematic, like black carbon. So there are improvements, significant improvement, and a good willing for doing something, but more needs to be done. Another challenge for the policymaker is that definitively PM pollution cannot be considered as a local issue. Of course, there are local issues, but if you want to manage efficiently this question, international cooperation is needed. And this is why it's so important to have those conventions and also those areas of discussion within the European Commission, and also this kind of conference where exchange of views develop. It's also very important to know more about source allocation. What is responsible for what? After, I have to confess that maybe it's difficult to use this information in terms of air pollution control strategy, but at least we have to improve our knowledge. And of course, we have to improve the knowledge in terms of monitoring data in some areas where there are less measurements. And this is also the reason why it's so important to support activities related to satellite and remote sensing measurements. This is a very, very famous graph which has been produced by the International Institute on Applied System Analysis, showing that definitively we cannot consider PM pollution as a local issue. So this is an average over Netherlands, German, and police stations. So just to have 3 different cases, and EASA allocated PM 2.5 level. I think it's for, I don't remember for which year it is, but they allocated those levels to various geographical sectors: natural part, international part, national, urban, street part. And what you can see is that in most of the cases, 10 is the WHO objective for the limit value, for the quality objective for PM 2.5. And what you can see is that in most of the cases, a large part of PM 2.5 concentration is really due to large-scale events, international, national scale events. This is really a basis for the work of policymakers. I have an example. I cannot, of course, escape. I have to talk about those French PM episodes that happened in 2014, this year in March 2015. We had very, very huge PM10 concentrations in France, but not only in France. Oh, sorry. Here, this is a map which comes from the Prévert system, which is the national air quality forecasting system in France. And you can see in red, this is where PM10 concentrations exceed 80 micrograms per cubic meters. So that means that on the 20th of March, but for several days actually, we exceeded this very high level. And here we have tried to simulate, in fact, the natural and foreign contribution to these concentrations. So that means that for the 20th of March, we estimate that 50% of PM10 concentrations come from other countries or natural contribution. But of course, when you look at this map, so you see that this is also red in other countries. If we do the same for the other countries, for Germany, we will find the same. We'll find that in Germany, 50% of the PM10 concentration come from abroad, especially from France. To be honest, French policymakers don't like this interpretation, but that's a fact. That's a matter of fact. So that really means that we have to do something together. And once more, this is my point. International cooperation is still needed. Just a last slide to ask you a question. In fact, during the last discussions that we had within the convention, there is a question that rose and that worries the policy community. This is a so-called condensable issue. So the particulate formation due to semi-volatile compounds emissions, which condense just after emissions. They are not in emission inventory. There is no trace of such compounds, semi-volatile compounds, in current emissions inventory. And they are not taken into account in chemistry transport model because they are not in emission inventory. So what to do with that? So we know that we underestimate or we don't take into account a part of the PM problem. And that means that maybe this is one of the reasons why there is always an underestimation of PM model results compared to measurement. This is not the only one reason, but it can be very sensitive. I think that there is really an urgent need for better quantification of those condensable regarding emission measurement modeling. And because it concerns several activity sectors, so residential heating, industries, but also road traffic. And we need to know now whether it can influence midterm projection for air pollution. Maybe we are too optimistic because this part is neglected, because not well known. So this is a question I would like to ask you. And I thank you for your attention.
Laurence, thank you very much for this wonderful talk. I enjoyed it really. So, and maybe it also gave to some of you, at least here, an impression of what people dealing with air quality issues struggle along with, and with health issues on a non-university scientific level. So I hope you like what Laurence was telling you. And are there any questions or comments? I see one up there. So, yeah.
Hi, James Allen, University of Manchester. Thanks for the very enjoyable talk. Just wanted to comment on that point on the last slide concerning the semi-volatiles. I heartily agree that we need to improve this in inventories, but would it not be a fair comment to say, even before we can improve it in the inventories, what we currently lack is a universally accepted method of quantifying these semi-volatiles instrumentally? So we don't even have a consistent way of measuring these things yet, these source studies.
Can I also pick up on this point? I would say that organic-based nucleation with sulfuric acid, or perhaps even without it, is the #1 source of particles in the boundary layer. So it's an extremely important thing. It's much more important than ammonia. In response to the comment that's just been made, there are instruments now that can measure exactly what's going into these clusters, causing the nucleation and also causing the growth. CI-It is a new instrument that's basically being developed. And so I think we've got very, very good information that's coming out over the last year or two. Some of it's unpublished, but the organics are extremely important. They're the #1 driver of what's going on.
Yeah, thank you.
Next one is there.
Lydia Morawska, Queensland University of Technology, Brisbane, Australia. I wonder what you think about the changes in transport technologies and what impact they will have on air pollution in Europe. In March this year, with this episode which you showed, Lord Mayor of Europe announced that in 5 years Paris will be all on electric cars and buses. Do you think it's real?
Really, managing those air pollution management in France, in Paris, you're right, we focused, the minister focused a lot on traffic and diesel. You know that in France, this is a very sensitive issue. I really think that the new technologies in transport will improve significantly the situation. Regarding PM emissions, the problem with a new diesel car is that, that's right, there are less PM emissions, and I think that it's okay. I'm much more concerned by emissions of NO2 and VOCs, actually, regarding those new technology. We don't know really what will happen, and this is also the reason why I point out this condensable issue. For me, the problem of traffic management link with PM episodes, this is a problem of really communication. When you reduce by, when you ban a certain amount of car, but not all, not necessarily the most pollutants, this is something that makes people, general public, sensitive, aware about the problem. In terms of efficiency, more reserved.
Okay, there's time for one more question. I think, yeah. Did I ignore you? Sorry, okay, let's make 2, but fast ones.
Laurence, you showed us this mismatch between decrease in PM and decrease in the precursors, but you did not tell us what you really think about what is the reason for this mismatch. So what are your hypotheses for this?
Really, I simply think that the real reason, the very simple reason, and this is very difficult to explain to policymakers and general public, is that all the phenomena that we talk about are strongly non-linear. And this is not because you reduce by a certain percent that the concentrations will be reduced by the same amount. And this is also the reason why I think that this is so important to understand more what happens, really the process, the chemical processes. After, it's impossible to explain to the policymakers or to the general public. It's completely impossible. We tried, it's impossible. But at least we need to know, to anticipate the answers, and also to define maybe more efficient reduction strategy. We know that because of the chemical regime, it will be, in some cases, completely usefulness to reduce some activities in some area. We know that because the chemical regimes makes it like that. And this is our duty to understand that and to inform at least the policymakers.
Okay, second last question is up here because the last question belongs to my co-chair.
Hello, I'm a PhD student at University and University of Bordeaux in France. I just wanted to ask how the policymakers are going to account the situation in Asian countries, because the air quality is a global issue. So, like, the condition is more worse in the Asian countries as compared to here. And they are still following the European and the United Nations legislations. So what do you think?
In fact, this is really the reason why cooperation conventions and negotiations are so important, to find the good compromises between the efforts that each country can provide. And that's right that I think it's not very useful for a city or a country to think alone about air pollution, because there will be the policymaker. It happens in some cities. I know some cities, especially in France, where very strong efforts are made trying to reduce emissions. And of course, because they are influenced by everything all over, the results is very disappointing. So communication, negotiation, and collaboration is a key word. I know that it's not easy. That's right.
Okay, last question now from you.
Thank you very much for your excellent talk. It's the opinion of a number of scientists present in this room, and we wrote a few articles on that the National Emission Ceilings Directive is not enough to reach the limit values or the WHO guidelines, and that we need to reinforce and to reduce the PM 2.5 limit values. It's not, I think we have 25 micrograms per cubic meter, and in US they have 12.5, and the guideline from WHO is 10. So we need to reduce that. We need to make limit and not target values the ozone and the benzylfapyrin values, because target values is nothing in the European legislation. And also some important emission sources like road dust. There is not a legislation for road dust, so the national emission directives can do nothing about that. And also specific sources, like you mentioned, biomass burning is very difficult to reduce emissions by legislation. So what is your opinion on that?
I fully agree. I fully agree that it will not be enough. As I say, there will be significant improvement. I hope that they will be confirmed, despite the fact that there are some big uncertainties. I agree with the sources that you mentioned, so road dust, biomass burning. This is the reason why I think that it's important to improve knowledge on those sources to see whether it's possible to have an action on them. Another point that I believe is that, okay, maybe we will reduce PM concentration, we will reduce exposure with knowing more about those sources, knowing more about condensable and the organic part. But at the end, I think that at time it will be impossible to reduce even more emission in our technological world, in fact. There are a lot of improvements are expected from technologies, significant improvement in technologies, but at the time, this is what everyone says, at the time it will be very difficult to improve furthermore. So I think that at the time, we will have to think in terms of structural changes for our society and for our cities. That means, but this is now that we have to think about this. That means that the policymakers will also have to think in terms of urban planning, not maybe reducing PM concentration everywhere because it will be impossible, but reducing PM exposure. That means reducing the areas, the locations where, reducing PM concentrations in the areas where people live, and avoiding that people live in very polluted areas. And this is really linked to structural changes of our societies. And to my mind, it's another step for the policymaker.
So, thank you very, very much again, Laurence, for this really wonderful overview and presentation. Thank you all for coming here, and I would like to ask you to stay because now it's time for the Smoluchowski Award.
Okay. Okay, thank you. Good morning, ladies and gentlemen. My name is Alfred Weber from the Technical University of Clausthal in Germany, and it will be my pleasure to guide you through the Smoluchowski Award ceremony that follows now. The Smoluchowski Award of the Gesellschaft für Aerosolforschung is intended to recognize outstanding contributions to aerosol science from a young researcher, usually under the age of 40. And the committee that found the awardee of this year is shown here. I would like to thank very much all the members, Jean-Pascal Bora, Yu Ko, Thorsten Hoffmann, Gerhard Kaspar, Einar Kruis, and Birgit Wehner for going through all the candidates we had. We had a half dozen of very good candidates, and one of them was outstanding, and he will receive the award of this year. And you see, he worked with very complicated instruments, which actually I always love in aerosol science, that we have complicated instruments. But he started his career as meteorologist, developing a condensation particle counter. Then he moved on in his PhD in chemistry to develop an ion mass spectrometer for aerosol particles. And then he ended up with the EAC2015 that you see here. So he has 38 peer-reviewed publications. Within the last 3 years, 16 of them. He has over 1,000 citations, an age index of 13, and he also fulfills the request of age. And as you see, to keep up the suspense, I have not shown his name here, but you will see he has made very substantial contributions to the formation of aerosol particles, and now we have just had a very exciting talk about the results of particles that are found, that are formed in air. He was concerned with the role of particles at the very beginning, and he made contributions to the neutral cluster formation during atmospheric nucleation. And this is a significant figure of his publication here, actually showing that very small sulfuric acid dimers are even stable and do not evaporate, and they are actually growing very close to the kinetic limit. But this is not my field. He will explain you that in a few moments. And we come to the awardee. Many of you know him. He is from the group of Joachim Curtius in Frankfurt, and his name is Dr. Andreas Kürten. Please.
Dear Professor Weber, dear award committee, I would like to thank you very much for awarding me with the Smolachowski Award this year. It's a great pleasure for me and a great honor to receive this prize. And first of all, I would like to thank Joachim Curtius from the University of Frankfurt for nominating me for this award. And also I would like to thank Rick Flagan for providing a support letter to the nomination. My special thanks really go to Joachim. He has always been a great mentor and a very good friend, starting actually from the very early stages of my career. And it's really been a pleasure to work with you, Joachim. I wouldn't stand here if I hadn't taken a few other steps in my career, and therefore I would like to thank Stefan Bormann and his group from the University of Mainz, where I received my PhD from. And then later on I went to Caltech to work there as a postdoc and really had a great time there and learned many things from the groups I had the opportunity to work with. And then also I would like to thank the cloud collaboration and led by Jesper Kirkby. As you will see in a minute when I show a few of my research results, most of them are related to the cloud project, and it's really been a pleasure to have the opportunity to work at the cloud project. And last but not least, I would like to thank all the students and co-workers I have worked with and who contributed to the research, of course. And in the end, I would also like to mention that the EAC conferences, they have always been a very inspiring environment for me. And it's actually now exactly 10 years ago when I was first participating in an EAC conference in Ghent in 2005. And standing now here 10 years later and receiving this prize, it really means a lot to me. So thank you for listening, and I will go on with a short presentation about some of my research results. As it was mentioned already, they are related to the formation of new particles, nucleation, and especially focus on the measurements of sulfuric acid and neutral clusters. So you all know that aerosol particles are really important for the Earth's climate because they are they can act as cloud condensation nuclei, and many of you will also know that only half of the CCN originate from primary particles, and about the other half originates from nucleation. So this is a really important process for the atmosphere. And nucleation starts with single molecules, and they can collide, stick together, form larger agglomerates, and then grow to become eventually stable aerosol particles. And as it turns out, sulfuric acid is a really important ingredient in this process, but it's not sufficient to have sulfuric acid alone for creating new particles at the conditions we have in the planetary boundary layer. So other compounds need to be involved. And schematically, I've shown here how nucleation in a two-component system would proceed, starting with a sulfuric acid monomer, grow on to a dimer, trimer, and so on. And there are a lot of questions involved in this process. For instance, what exactly is the compound X? For sure, water is participating in this process, but what about other compounds like ammonia, amines, or organic molecules? So there's a lot we have to find out here. And then, of course, is there maybe, or are there maybe other precursors, main precursors besides sulfuric acid, which can initiate this process? And in the end, we are actually interested in the evaporation rates of these clusters, because this is actually what controls the magnitude of the nucleation rate. So ideally, in order to model nucleation, we need to know these properties for each of the clusters and the influence of temperature and relative humidity, for instance. So how do we look at this process? For the relatively large particles, we have condensation particle counters and DMAs. These start around a few nanometers, and then we can observe these typical nucleation bananas. But if you want to know something about the chemistry going on here in the very early stages of nucleation, we need to apply mass spectrometry. And the keywords here are SIMS, for instance, chemical ionization mass spectrometer. This ionizes the neutral molecules and the clusters, and then these can be measured inside a mass spectrometer. And one of the latest developments is this so-called CI-Apitof. And here I have to acknowledge co-workers at University of Helsinki and especially also Doug Worsnop from Aerodyne for inventing this instrument. So I mentioned this already. Most of my recent publications are related to cloud. This is this project going on at CERN. We have a huge stainless steel aerosol chamber, and there we can look at the nucleation and growth processes in a very controlled way. And this is really the key, actually. We have typically these run plans here where we vary certain parameters, and then we can actually identify the isolated effect of one parameter on the outcome on the nucleation rate. And this is really necessary to understand the processes that are going on. So one example of these measurements that were conducted, besides many others, was this test of adding sulfuric acid, dimethylamine, and water vapor to the chamber, and then use this new technique, the CI-Apitof, to actually observe the clusters in real time. And this study was conducted at atmospherically relevant sulfuric acid concentrations, which you can see here. This is the sulfuric acid monomer, about 10 to the 7 per cubic centimeters. That's what you typically find in the atmosphere. And with the instrument, we could then actually follow the appearance of clusters containing up to 14 sulfuric acid molecules, starting really from the monomer. So this technique bridges the gap between single molecule and particle. So this 14 SA molecules are about 2 nanometer in size, because you have to recognize that there are also dimethylamine molecules involved in this large cluster. So this is really a key instrument in the cloud project. And then, as it was already mentioned, we were able to come up with the conclusion that already a very small cluster containing just 2 sulfuric acid molecules can be regarded as a stable aerosol particle in this system. So this actually is the explanation why the nucleation rates that can then be derived for the system at a larger diameter of 1.7 nanometer are compatible with what we find in the atmosphere in terms of the nucleation rates. So this mechanism would be one that is in principle capable of explaining atmospheric nucleation in the atmospheric boundary layer. And this study was conducted at 278 Kelvin, so it's relevant for the lowermost layer in the atmosphere. But also the free troposphere is, of course, important for particle formation. And as I said earlier, sulfuric acid is not capable of doing the job alone. But if you go really to low temperatures, then the evaporation rate of these clusters in the binary system between H2SO4 and water, they decrease dramatically, and this actually then allows binary manipulation to become compatible as well. And in cloud also we studied cluster formation in the binary system at this low temperature, and there we were also able with the CI-Apitof to measure the neutral clusters containing up to 10 sulfuric acid molecules. In this study we also investigated the influence of ammonia on the cluster formation. And the goal here is really to derive the thermodynamics of the clusters experimentally and eventually model new particle formation also for the ternary system with ammonia in the upper troposphere for the cold temperatures. So with this short overview, I would like to end this presentation. And thanks again to the award committee for awarding me with this prize, and thank you a lot for your attention. Thanks.
So, Dr. Kuhn, it's my pleasure now to give you the certificate for this award. And please stay. There will be some other messages right after this ceremony. And you also receive money for this prize, I think 2,000 euro, that will be handed out by the treasurer, Gunther Metzig of GAF. And so with this, I congratulate you.
Please stay here because there are some announcements given by Claudia Sorlini, the President of the Expo Scientific Committee.
It is a pleasure for me to be here. I wish to thank very much the Scientific Committee for invitation. The title of my very short communication is Feeding the Planet, Energy for Life in a Sustainable Way. Feeding the Planet, Energy for Life is the theme of the Universal Exposition at Milano. And the real challenge is to feed the planet without to consuming natural resources to contaminate the environment. So because we need to preserve the natural resources necessary for the future generations. Over the past 50 years of Green Revolution, I remember that the Green Revolution is based on the use of the chemicals, pesticides, fertilizers, and so on. The production of cereals has trebled, whilst the population has doubled. As you can see in the slide, there is a dark green is increasing of population, and the light green is global cereals production. But during these 50 years, we have had also a huge quantity of agrochemicals spread in the environment. What is the future scenario? Food demand grows quicker than food offer because world population growth and because increased the demand of food from of animal origin. And the forecast for 2050 are that in the world we will have 9 billion people, and food demand and water consumption will increase very, very hard. The impact of agriculture. We know that agriculture is very important in order to supply food for populations, but agriculture is also responsible of 14–17% of total greenhouse gas emissions, in particularly from ruminants breeding. And agriculture is consuming also 70% of fresh water in the world. Moreover, it is exploiting too much soil fertility. Environmental pollution, we know that environmental pollution in this Congress, I know that you are very expert in this field, is important because we will have several consequences. Greenhouse emissions that are changing climate, tropicalization of the temperate zones, losses of agricultural productivity, harm to the health, ecosystems modifications. Climate change will impact on the productivity, agricultural productivity. In fact, some researchers estimate that 25% loss of food at low latitude This loss will not be balanced by a small increase of production in some temperature zones. Water consumption. We are consuming a lot of water, and we have a very high water footprint. In particular, water consumption increases twice as fast as population growth. And as regard energy consumption, we know that 80% of planet energy comes from non-renewable energy, in particular from fuel. Biodiversity loss. Today, only 30 species of plant, over 7,000 domesticated since the origin of agriculture, are cultivated for supply food. During the 19th century, 75% of plants' biodiversity has disappeared. What can do scientific research in the field of agriculture? We have a lot of things to do. For example, you can reduce agrochemical in agriculture by selecting plants with a high nutrient absorption efficiency. Moreover, we can select plants able to produce active biomolecules against pests and pathologies in order to reduce use and consumption of pesticides. Moreover, you need to reduce the impact of animal breeding, in particular on the pollution. We know that ruminant produce a lot of methane by digestion of the product, of the food, and methane production can be controlled by both diets, but also by inhibitors of the transfer of electrons from hydrogen to carbon dioxide. Moreover, you can use also microorganisms to promote plant growth in dry lands. It is possible to select bacteria existent in the soil, able to biofertilize the soil because they provide nutrients. They are able to modulate the hormonal balance in the plant and also to protect the plants from phytopathogens. Moreover, a lot of research are addressed to look for new genes to improve the food nutritional values. For example, you are discovering that ancestral wheat, for example, but there are a lot of other examples, owns genetic information associated to iron, zinc, and proteins bioaccumulation. I think that the contribution of the different fields of environmental chemistry is very important, is fundamental, because life, nutrition, quality, and health are strictly linked to the environmental quality. In industrialized countries, several progresses have been made, but in large areas of the world, the environmental quality is dramatically low. I think that the Universal Exposition of Milano has contributed to disseminate information and increase the sensitivity on the problem of hunger in the world and on the necessity of sustainable development. I invite you to visit the Universal Exposition of Milano. Thank you very much.
The last quick information, tomorrow morning after the plenary session, we will take here the traditional picture of the European Aerosol Conference, so all of you are invited to participate. Thank you and enjoy the coffee break.